Okay, I welcome all the students. Today we are going to learn the topic flood fill algorithm. Okay, we have already started understanding the point filling area primitive. Okay, so under the filling area primitives, we already have discussed what is the scan line polygon filling algorithm, or how we can go for the scan line, okay, filling the algorithm, or for any polygon we can fill with the help of the scan line. Then we have seen the point inside outside test. Okay, and then we have seen in the last session, okay, how the polygon is filled with the boundary fill, or we can, I think we have learned the seed fill algorithm. Okay, so today we are going to discuss the topic, okay, flood fill algorithm. Okay, so today's the point of discussion, okay, which we can say as one of the last point under the flood fill primitives. So we are going to learn what is flood fill algorithm, okay, how it is different from the boundary fill and all other types of the filling algorithm. Sometimes, or we are finding that some of the cases we want to fill an area, okay, we want to fill the polygon, or we want to fill the area that is not defined in a single color boundary. Okay, so I'm having the polygon, or we are having the area which we want to fill with the algorithm, or we want to fill with the computer graphics method, which is not, mean that area which I want to fill is not defined by a single color boundary. Okay, it is not defined by a single color boundary as shown in the diagram. Okay, if you are looking to this particular diagram, you come to know that this is the polygon, or this is the area, okay, of the polygon which is having the multiple boundaries. Okay, so if I consider this boundary of the polygon, you can find that this is having the color as the red color. So obviously this boundary of the polygon is having the red color. This boundary of the polygon, if I'm considering, it is having the blue color. Okay, so this is different. If I considered, okay, this particular, okay, boundary of the polygon, so again it is of the different color. Okay, so I want to fill this polygon, okay, but the different edges of the polygon or different boundaries of the polygon are having different color. Okay, because what we have done into the third previous algorithm as a boundary fill algorithm, okay, what we have done in the boundary color algorithm is, whenever we start the seed pixel, or whenever we're starting with the one pixel, suppose I consider this is my interior pixel, and then we just goes on filling this pixel till the end of the, or till it reaches to the boundary color. Okay, but now here the difference is, okay, as shown in the diagram, an area bordered by, so the area of the polygon is bordered by several different color regions. Okay, so I cannot say that my boundary of the polygon is only red color, because this part is red color, this particular part is of the blue color, this is again different color. Okay, so in such a case, okay, the boundary fill algorithm or the seed fill algorithm we have learned, okay, will not work. Okay, so in such a case, we have to take the help of the flood fill algorithm, or we will go for the use of flood fill algorithm. Okay, so the point of discussion is the difference between boundary fill algorithm and flood fill algorithm is that in the flood fill algorithm, the area of the polygon, okay, the area of the polygon which we want to fill with some color has bordered with, has boundary having several different color regions are used, okay, as a boundary color. Means the boundary is not of a single color, it is of the multiple color as shown in the diagram. Okay, so now the next point that we are going to consider here is we can paint such areas. Okay, now how to paint such areas, how to fill this such areas. Now we can paint such areas by replacing a specified interior color. Okay, by replacing a specified interior color instead of searching for a boundary color value. Okay, So in that case, now I'm not searching. Okay, suppose this is my seed pixel or this is my interior pixel. Okay, so what I'm going to do in this case is I'm consider that whether this interior pixel is having the old value or previous value is white. Suppose this the background color or interior value of this polygon is white. Okay, and now I want to fill with the new color or fill color. Then I will just compare, okay, that whether this pixel is already having the old value or I'm just considering it is interior color. Okay, replacing the interior color. Now the interior color of this pixel is suppose white. Okay, interior color is white. Then replace this interior color with the fill color or polygon color which I want to fill this. Okay, now instead of searching for a boundary color value, okay, because if I search for the boundary color value, then the question comes is if I go to this particular boundary, it is different color, this boundary is of different color, this boundary is also of the different color. Okay, so in such a case, okay, what is the method that we are going to apply is we can paint such areas by replacing a specified interior color. Okay, instead of searching for the boundary color value. The reason is why not to depends upon the boundary color value, because the region I want to fill or the area I want to fill is having multiple boundary colors. Okay, that was the reason, okay, that we will go for the flood fill algorithm, and this approach of filling the color is nothing but it is known as flood fill algorithms. Okay, so this is what we are considering it as flood fill algorithm. Okay, the flood fill algorithm will consider the interior color. It will take the interior color into account and it will not depends completely on the boundary color values. As shown in the diagram, this area, okay, which I want to fill is defined with the having or it is having the multiple color boundaries. Okay, as the multiple color boundaries, okay, this algorithm, flood fill algorithm, will not base completely on the boundary color. Okay, that's why it is not boundary fill algorithm, so it is called as flood fill algorithm. Okay, so let us understand the flood fill algorithm in detail. So definitely, obviously, it will be more similar to the boundary fill algorithm, okay, with some changes or modification. Okay, so I'm just moving to the next slide to continue our discussion or to understand the procedure of flood fill algorithm. So now we are going to understand or we are going to consider what is the steps or the procedure of flood fill algorithm. Okay, now here also what we are going to do, we consider the same diagram because this is the diagram which shows that why there is a need to go for flood fill algorithm. Okay, so in this procedure, okay, the first point is we start from a specified interior point x comma y. Okay, now this flood fill algorithm also required the interior point should be known to us. Now in this particular diagram, in this particular polygon, suppose I consider this is my interior point. Okay, I have shown in the diagram this is my interior point. Consider it is having the value x comma y. Okay, xy value of an interior point. And what we are going to do is and reassign all pixel values that are currently set to the given interior color with the desired fill color. Okay, now once I know this interior color, okay, what we are going to do is we are going to reassign all the pixel values that are currently set to the given interior color. Means I will just goes on checking all the values whether they are already set to the interior color. Okay, so my interior color in this case is suppose white. Getting me? So you can consider this is my interior pixel or this is my first pixel. Suppose this is having the color is white. Oh, interior color will be white, then I'm going to fill this with the desired fill color. Getting me? So my desired fill color itself is again I consider it as suppose hey, I'm having the pen or ink with the brown color, then I will just fill this pixel with that particular color. Okay, so I will fill this with this and again I will check. So all the pixel now I'm have to find out whether it is already having the interior color. So my interior color, suppose I consider it as white. Okay, so W indicated is white and desired color I want to fill is with brown color. Okay, so my fill color is brown, my interior color is white. So accordingly, I'm going to search, okay, and start filling the color. Okay. Now, if the area, coming to the next point, next step of the discussion, if the area we want to paint, okay, so this area I want to paint has more than one interior color. Okay, so this may happen, means this area may have the interior color is not only the white, it may have any other color, multicolor. We can, if that is the case, now that is not there is the case in the diagram. Okay, but my interior color, the area which I want to paint may have the different color. Then what we have to do is we have to first reassign pixel values so that all interior points have the same color. Okay, now suppose this is my white color, so interior color of this particular triangle. Okay, if I consider this is my triangle, okay, so this triangle is already having the same color, interior color is white, boundary colors are different. Okay, look at this, the boundary of this polygon, every edge is of different color, but the interior color is white. Okay, but what algorithm says that if the interior is also of the different color, okay, some part of this polygon is white color, some part of the polygon is other than white color, some part of this with maybe a different color. Okay, so if it is having multiple interior color, then what we have to do is we have to first reassign the pixel values so that all interior points have the same color. So what I will do, I will just fill all this interior initially with the white color, so that I know that my interior is white color, just now we have seen, and I have desired color I want to fill it, suppose it is brown. Okay, so now I can find out what is my interior color. Okay, you may consider interior color as a background color, maybe background color is same, and then I want to fill it with the desired color. Okay, so that is what we have to do. Now once this is over, means once I got, or once we came to know that, or once we have assigned that all the interior colors are of the same color, or interior points or pixels are of the same color. For example, my all interior colors are white, and now I want to fill it with the brown color or the desired fill color. Okay, in that case what we are going to do is, then now we will apply our same method as we have used in the boundary fill algorithm or seed fill algorithm, that is using either 4 connected or 8 connected approach. Then now we will go to use the 4 connected or 8 connected approach, and we then step through the pixel position. Okay, so now we are going to consider the 4 neighbor pixels. We are going to connect the 4 neighbor pixel until all interior points have been repainted. Okay, all interior points have been repainted. So what we are going to do, suppose this is my seed pixel or interior pixel, and it is already having the background color, or we say interior color is white. I have filled it with the brown color. Then I'm going to check the its 4 connected pixel. Okay, we are knowing the 4 connected pixel are in the form of left, right, okay, up and down, okay, or above and bottom. So we are considering the 4 connected pixel. Again, check whether this interior neighbor pixel is having the interior color. Interior color is white. If it is already having the interior color white, yes, fill it with the desired color. Okay, so in this way the complete polygon or complete area is filled with the color. Okay, and that is what is expected to do in the flood fill algorithm. Okay, so this will be continue. Okay, and it will now here, if I whenever I come to the boundary, see, understand what is the difference between boundary fill algorithm and flood fill algorithm. So whenever I come to the boundary pixel, okay, then this boundary pixel is not having the color interior color, because interior color is white but the boundary pixel is having the blue. Okay, so I will not check whether I have reached to the boundary. I will check whether it is already having the interior color. No, it is having the blue color because my interior color is white. Okay, so I will fill this. Okay, whether I'm going to fill this color, no, I will not consider that pixel. Okay, so if I come to this boundary, again I will check whether this pixel, this boundary pixel is all having the color interior color white. No, it is having the boundary color red. Okay, if it is boundary color red, I will not fill it. Okay, so due to this, what is going to happen, though my region is surrounded by different boundary colors, okay, I'm not considering the boundary color here, so automatically it will not have any issue related to the boundary. Okay, because I'm just considering the difference between, if the pixel is already filled with the interior color, if it is having the interior color, fill it with the fill color or desired fill color. Okay, so in this way this algorithm works. Okay, and again this algorithm also uses the 4 connected or 8 connected approach and continue with this. Okay, I hope all of you understood the procedure, okay, that is applied into the flood fill algorithm. So in flood fill algorithm we just check whether the pixel is already having the interior color, fill it with the desired color, and the procedure is continued considering the 4 connected and 8 connected pixel. Okay, but there is no need to consider the boundary color, or there is no need to consider boundary color, because the boundary is surrounded by multiple color. There is no single boundary color, so we are not considering the boundary value. Okay, now the same flood fill algorithm we can use recursively, as we have seen the boundary fill or seed fill algorithm. So just I am moving to the recursive definition or recursive program of the flood fill algorithm. Okay, so I just move to the next slide to understand the algorithm or recursive definition. Okay, okay. So this is what the recursive procedure for the flood fill algorithm. Okay, the following procedure flood fills. Okay, so this is the procedure for flood fill algorithm. It flood fills 4 connected regions. So we are considering here 4 neighboring pixel or 4 connected regions recursively. Okay, starting from the input position. So my input position is obviously any pixel which is interior to the polygon. Okay, which is interior to the polygon, and then we are going to, okay, consider the 4 connected region approach and just goes on filling the color or filling the area. Okay, so just look at the name of the procedure or name of the recursive function is flood fill 4. Okay, so I'm going to use the flood fill function, flood fill 4 recursive definition. Now what input it is required? Okay, what thing should be passed to this function is integer x and integer y. See, this integer x and integer y will be, when I call this function first time, it is my input position. Okay, it will be my input position, means it is my interior pixel. Okay, any interior pixel I'm going to pass as x and y. Okay, so suppose I just want to consider, okay, this is, okay, one of the polygon area that I want to fill. Obviously the borders are different. Okay, so in that case, okay, this is my first pixel which is the interior, and this will be act as my initially x and y value. Okay, now then I have to pass what is the fill color. Suppose I want to fill this polygon with different color, or suppose it with the blue color. Okay, suppose I want to fill this polygon with the blue color, then my blue will be the fill color, and it is another thing I am going to pass is old color. So in this case the old color is nothing but the interior color. Okay, so interior color means background color. So background color is white. Getting me? So this pixel is having the background color as a white. So now my white becomes the old color. Getting me? So in that particular case, I know that what is my old color? My old color is white. Getting me? So WHITE. So I just write it here as white. So white is my old color. My fill color, suppose I take this as a blue. Okay, so I considering my fill color is blue in this particular case. Okay, so blue is my fill color. Okay, my fill color is blue now, and I just consider it as a old color is white. Okay, now what I'm going to do first, what is my step number 1 then? Okay, after giving this input, so this is my seed pixel x and y, fill color is blue, my old color is white. Okay, step number 1, I will go for get pixel x comma y. Okay, now get pixel x comma y means I will take get color. Get pixel is going to return the current color of x and y. So what is the current color of this pixel? It is white. So whether it is equal to old color? Yes, my old color is white, and the current pixel is having the old color. Getting me? So then what I have to do? I have to set color fill color, or I have to set that particular pixel with the fill color. So my fill pixel color is blue. Okay, so I just take the blue ink now, and what is I'm going to do? I'm going to fill this particular pixel with the blue color. Okay, so this particular pixel is filled with the blue color. Okay, now once I'm going to fill this pixel with the blue color, what I have to do, I have to recursively consider, or I have to go through the all four connected neighbors or adjacent pixel, or four adjacent pixel or the neighbor colors. Now I will take the first pixel is x plus 1 comma y. So if this is my seed pixel, this is my x comma y, then this pixel will be, the next pixel will be x plus 1 comma y. So this is my x plus 1 comma y. Okay, then I will just check for x minus 1 comma y. So this is into the right direction. So this will be, okay, from our point of view, this will be left side or left position, x minus 1 comma y. I consider x comma y plus 1. Okay, so if I consider this pixel, then I come to know that this will be my x comma y plus 1, and my fourth neighbor is x comma y minus 1. I'm going to consider the x comma y minus 1. So I'm going to consider this all four connected pixel. Getting me? Now I'm going to call this flood pixel with x plus 1 comma y. Okay, suppose this is my first recursive function call, so this will be calling this recursively. It is going to call this flood fill recursive function now by passing x plus 1. So my x plus 1 will now, my x plus 1 will becomes x now, and y will be y as it is. Okay, so now in that case, which is my current pixel? Now this x plus 1 comma y, this will be my current pixel now. Okay, and now for this current pixel, okay, I will again, this will be now become my x plus 1 will become x, and y will be as it is. So I will again check, I will get the color of this pixel. I will check what is the color of this x plus 1 comma y. Okay, obviously I will get it is white. Okay, again it will check whether it is equal to old color. Yes, it is old color because white is my old color and current pixel is having the white color. Okay, so what I will do, I will set the color fill color, or I'm going to fill this with the fill color. What is my fill color here? My fill color is blue. So what I'm going to do is I'm going to fill this particular pixel with the blue color. Getting me? So this color, this pixel is filled with the blue color, and in this way it will be continued. Getting me? Now here the question is, in this way when I reaches to the pixel which is having the brown color, or this is boundary color. Okay, so boundary color, suppose I consider it may be any color. Okay, it should be other than the fill color and old color. Okay, it should be other than the interior color and fill color. So suppose I come to this particular pixel, then this pixel is having, okay, when I use the get pixel function, then this pixel is having the color brown. Okay, it is having the color other than blue and white. So it will check whether it is having the old color. No. So obviously the algorithm, or this is my end condition. Okay, recursive condition will be end here. It will come back to another case and start searching for the x minus 1 in this direction, and the procedure is continue, and in this way we are going to fill the complete polygon. Okay, so this is what we are having, the recursive flood fill algorithm function. So we are having the flood fill algorithm. Okay, it is called recursively. If I am considering 4 connected, I am calling this 4 neighboring pixel recursively. If I am having 8 connected, so I am going to consider the remaining 8 pixel also. Okay, so that is what the procedure that we are following for the flood fill algorithm. In the flood fill algorithm, if I compare with the boundary fill algorithm, okay, you come to know that I think I am reaching to the color as the boundary color is, instead of old color. In the boundary fill algorithm, we have used boundary color here. Okay, we are checking up to the boundary color. Okay, I'm having and condition, this is having the old color and it is not the boundary color, then fill it. Okay, but here we are not considering boundary color, we are just considering the old color as the interior color, okay, or background color. And if it is having the interior color or background color, fill this with the fill color. Okay, and this procedure is followed recursively by the flood fill algorithm. Okay, I think you have understood, okay, the flood fill algorithm in detail, or its recursive function in detail. Okay, so we continue the flood fill algorithm discussion. Okay, and we will try to whether it is possible to optimize the algorithm. Okay, or whether it is possible to have a minimum storage requirement, how I can achieve it. Okay, so I'm just moving to the next slide to continue the discussion. Okay, Now you can find it here. Okay, we can modify the procedure of flood fill 4. Okay, whatever just now we have learned for the recursive function flood fill 4 algorithm is very correct, no issue. Okay, it will give us the expected result. Okay, but we can modify this procedure, okay, to reduce the storage requirement. Okay, to reduce the storage requirement, because it will require more storage space. So to reduce the storage requirement of the stack by filling the horizontal pixel span. Okay, so if we considered, if we just goes on filling the horizontal pixel span first, okay, then the storage requirement of the stack will be reduced, and though the object size is large, I think will not get the error as a stack overflow. Okay, my stack requirement will be reduced, my stack storage will be reduced, then there is no possibility that I will have the error stack overflow. Stack will not overflow because the requirement is reduced. Getting me? Now if I want to reduce the requirement, what we have to do? So in this approach, okay, we stack only the beginning position for those pixel span having the value old color. Okay, means initially whenever I'm going to stack it, okay, what I'm going to do, I'm just going to stack only the beginning position of those pixel span. Here the span is horizontal pixel span having the value old color. Okay, so I've just considered the old color having the value, and then I'm going to start doing it. And now in this particular area I just go for the horizontal pixel span. Okay, now for example, okay, so consider this particular diagram. Okay, so this will be the similar approach that we have used in the boundary color. Okay, the similar approach of the boundary color we are going to use here, but our purpose is to reduce the storage requirement. Okay, to reduce the storage requirement we are going to use the horizontal pixel span. Okay, for example, I'm just show in the diagram number A. In diagram number A, consider this is my start position. Okay, this is my starting position. Okay, so start position is this. Whether it is having the old color, because I'm using flood fill algorithm now, I will consider whether it is having the old color, means interior color, yes. So I'm going to insert this as my initial pixel. Okay, and at that, then what I'm going to do, I'm going to scan this horizontal span. I'm going to consider the horizontal line till now. Why I when I reach to this, okay, this particular pixel, or when I reach to this particular pixel, this pixel or this pixel, so this pixel is not having the interior color, or it is not having the old color, so obviously this will not, my algorithm ends here, or it will not fill with the fill color. Okay, so then I will move to the next position, okay, which is again horizontal span. So I am going to use the approach of scan line or horizontal pixel span. I'm going to consider to reduce the storage requirement. Okay, now how this pixels, how this scan lines, or now I say horizontal span or horizontal scan lines will be inserted into the stack. And to understand how this will work in detail, so I'm just moving to the next slide so that we will understand the horizontal span, how I'm going to consider it. Okay, means instead of now inserting, okay, all the 4 connected pixel into the left direction, right direction, up direction, down direction, I consider that I'm going to insert the one horizontal span, and or you can say one horizontal scan line. So we can say we are going to use the scanline approach of the polygon filling as well as the flood fill, okay, algorithm combined. Okay, and that will help us to reduce the storage requirement of the stack. Okay, so now to understand this particular point in detail, okay, I just move to the next slide to understand the stack requirement. Okay, we already have learned the flood fill algorithm, recursive function. Okay, now we are just talking about the improvement which is possible into the flood fill algorithm. Okay, so just I'm moving to the last slide of today's discussion. Okay, I just now mentioned the steps are similar to those that we have seen into the boundary fill algorithm. Okay, so let us understand this particular point. Okay, Now if you are looking to this diagram number A, okay, so if you are looking to the diagram number A, you come to know that I'm just now considering, okay, suppose this is, see what we are going to consider in this particular case is, suppose this is my interior pixel, okay, so this is my seed pixel, okay, so we have written starting at the each position of each span, so this is my starting position now, okay, diagram number A, you can find this blank pixel or pixel having the background value is my starting position. Okay, now once I get the starting position, now I'm considering that I go to, or I'm going to consider the complete horizontal span over here. Okay, I'm going to consider complete horizontal span, I'm going to fill with color, and this horizontal pixel on the same scan line I'm not going to input or insert into the stack. Okay, because if I insert all this pixel 1 2 3 4, or I'm having, suppose on this scan line, any one scan line or horizontal span, I'm having hundreds of pixels, so there is no need to insert all these 100 pixels onto the stack. Okay, instead of that I consider this is my current scan line. Okay, and after that, so the pixel values are replaced until the valued other than old color is encountered. Okay, because so I just goes on filling this horizontal span when I encounter the pixel. Now I will not say it is a boundary pixel because other than old color. Okay, if whenever I encounter other than old color, because my old color is white and this color is blue, so it will end or it will stop. Okay, after that what I am considering, I'm going to consider this. Okay, in that case is, this is my scan line number 1, so my initial scan line inserted onto the stack is 1, and when this is filled I will go for the 2, scan line number 2, so I have inserted this as a horizontal span number 2, so this is my 1, then I will go to the 2. Now you can look in the diagram number B. Okay, in the diagram number B, what I have done, okay, 1 is already my initial value, then this is my, when I go to the up, this is my second horizontal span, so I have filled this second horizontal span, you can find in the diagram, I'm just highlighting this, we are going to fill this horizontal span. Okay, now after filling this horizontal span, okay, this is my first, this is my second, obviously I will move to the next horizontal span, and that is my scan line number 3, you can find that this is my scan line number 3 completely. Okay, so the, in the stack, instead of inserting all the neighbor pixel I have inserted, now I have to move to the horizontal span number 3. Okay, and you can find in the diagram number C, this horizontal scan line or span 3 is filled. Okay, this is my 3, this is 1, this is 1, this is 2, and this is 3, this is my 1, this is my 2, and this is my 3. Okay, now in diagram numbers you can find all this horizontal span is filled with the fill color. Okay, and then I will move to, now this may be my, as it is having the different boundaries, so this is my span number 4, this is my 5, this is my 6. Okay, so this is inserted. Now suppose my initial pixel I have reached up to this particular pixel. Okay, come to the diagram number D, this is my current pixel. Okay, then I have to insert the span, okay, horizontal span 4 and horizontal span 5, means this 5, line number 5, this is 4, so that is inserted here, and again I just goes on filling it and the procedure is continued. Okay, so the advantage that we have uh, considered in this particular approach is there is no need to insert all these pixel on the stack. Okay, so if I'm just goes on adding all these neighboring pixel onto the stack, my stack requirement will be increased. Okay, so to reduce this stack requirement, I'm not inserting all the neighboring pixel, rather I'm going to insert the horizontal span line. Okay, so horizontal span on that particular, I may have 4 pixel, 10 pixel, 100 pixel, so instead of 10 or 100 pixel I just insert that this is my horizontal span number 1 or 2 or 3 4 5. Okay, so the number of values which are inserted in my stack will be reduced. Okay, and that is what the, we can say, the complete modified version of the flood fill algorithm. Okay, so we have modified the flood fill algorithm. by considering the scan line approach, or rather I can say it is considered here as a horizontal span approach. Okay, so once I get one pixel, see, once I get one interior pixel of this, I'm going to completely fill this horizontal span, all the pixels on the horizontal line. I'm going to fill it, and I will not insert all these pixels on the stack. Then I will just insert the line, horizontal line, which is above it or below it. Okay, and this is the main advantage of making the modification into the flood fill algorithm. And we just now seen the purpose is to reduce the stack requirement. And if we reduce the stack requirement, or if we not going to put so many values into the stack, then I will never get the error as a stack overflow. Okay, and my algorithm will work very correctly, and the storage requirement or the memory requirement for the algorithm will be reduced. Okay, and that is what we have shown into this particular approach. Okay, so I hope all of you have enjoyed, okay, learning the last algorithm under the polygon filling algorithm, or fill primitives. Okay, polygon fill primitives. Under this we have learned the as we are considering that we have learned the four important points under this. Okay, the first point we have learned is scan conversion polygon or scan line converting polygon. Then we have seen inside outside test. Then we have seen boundary fill algorithm, and just now we have learned the last point is how this flood fill algorithm works. Okay, or how we are in a position to modify this flood fill algorithm also to reduce its drawback of the storage requirement. Okay, or we have minimized the storage requirement of flood fill algorithm. Okay, okay, I hope all of you enjoyed it. Okay, so we end our session here. Okay, thank you all the students.